All right, in example number 10, we have a particle that's moving along a line so that its velocity is given by this function. So its velocity is changing quite a bit with respect to time. We want to know the displacement of the particle on the time interval from 1 to 5 seconds and the total distance traveled by the particle. Now, remember, this is velocity. If we want displacement and distance, that's a position function. So we're going to need to take the antiderivative of velocity to find both of these, okay? Because we want to, displacement and distance are related to position. Now, I graphed this over on Desmos. You can check it out as well if you want to stick it over there. But basically what's happening from 1 to 5 is it looks something like this. It crosses at 1, at 4 and 5. So it's like here and here. This is the velocity function. Okay. So if we want to find displacement, we'll do that first. This is displacement. We're just going to do the whole thing. We're going to take the antiderivative from 1 to 5 of this entire function. T cubed minus 10t squared plus 29t minus 20 dt. Okay, we're just going to take the antiderivative. Okay, so the antiderivative is going to be 1/4 t to the 4th minus 10/3 t cubed plus 29/2 t squared plus 20t. And we're going to evaluate that entire thing from 1 to 5. Now, I'll let you do all the arithmetic. When you plug in 5, you get 25/12. And when you plug in 1, you get negative 103/12. So when we put this all together, we get 32/3. Okay, so since this is positive, that means we have a positive displacement. So the particle moved 32/3 to the right. So it moved 32/3 feet to the right of where it started. Okay, so that's displacement. Now for total distance traveled, here the velocity is positive from 1 to 4, which means our particle is moving to the right. And then it turns around and it moves to the left. Okay, so what happened when we did the total displacement is basically this part got subtracted. We don't want that anymore. We want to do these separately. So we want to do the distance it moved to the right and then also do the distance it moved to the left and combine those. So what we'll have to do from that is we'll need to consider the distance from 1 to 4 of our function. I'm just going to call it v of t right now because I don't want to write it all out. And then we want to add the distance from 4 to 5 of v of t. Now, that is going to be a negative number, so we're going to have to change the sign on it. Okay, so this is what we're going to end up doing. Basically, we're going to take the antiderivative of velocity from 1 to 4 and then subtract from 4 to 5. So when we take the antiderivative, we get the same thing we got over here. Is it okay if I don't write all that down? It's the same thing as over there. We're evaluating from 4 to 1 minus, it's still the same thing as we got over there. And we're going to evaluate from 4 to 5. So when you plug in 4, you get 8/3. When you plug in 1, we get negative 103/12 again. When we plug in 5, we get 25/12. When we plug in 4, we get 8/3. Again, I'll let you do the arithmetic on all of that, but this turns out to be 45/4 minus negative 7/12, which turns out to be 71/6 feet. Okay, so this is the total distance traveled, because basically what we did is we took from 1 to 5, we took the absolute value of that velocity. Okay, so that obviously needs to be more than our answer over here. Okay, so that is displacement, and this was total distance. I didn't write that down. So I apologize for the terrible handwriting, but hopefully those problems made sense. Feel free to email me if you have any questions.